Hello and welcome to the segment number 8 of the course, Geographical Peculiarities of Kuttanad, Solutions to Environmental Issues of the Place through Engineering. So, in the previous segments we have been discussing with regard to the geographical peculiarities of the place, the issues due to flood, the features of flood affected Kuttanad, the flood mitigation measures, flood adaptation measures, and then we have discussed about the structural failures and the various reasons for structural failures and some of the protocols which could be adopted for resilient construction. And then in the segment number 7 we discussed about some of the case studies employing those kind of protocols which were formed with the help of the site visits as well as with the help of the discussions. So, in segment number 8, one of the other major important environmental issue is going to be discussed, that is the Polder walls, the Padasekaram walls or the Polder bunds. So, strengthening of Polder bunds is extremely important to maintain the biodiversity of the place and to maintain the agricultural produce of the place. So, appropriate construction for Polder wall strengthening is going to be the subject of this particular segment. So, before we go into certain protocols for Polder wall strengthening, let us look at this particular picture. This is a picture of a Polder wall breakage which happens very frequently in a place called Kanagasheri. So, Kanagasheri Polder is very infamous for its breakage. On the left side you can see the Kanagasheri Polder. It is a polder, but you see it has a continuous water body. The photograph is taken after water has been entered into the Kanagasheri Polder. On the right side of the Polder wall you can see the Vattakayal. Vattakayal is part of the Vembanad lake. So, the depth of water in the Kayal or the lake on the right side and the depth of water on the depth of the polder on the left side are almost close to each other, like 8 meters. That is unusual. Usually the polders will be having a depth of 1.5 to 3 meters only, and on the other side the water bodies will be having a depth of say 2 to 3.5 meters only, not more than that. But here the scenario was extremely different. The depth of water is very much. So, we require the polder like a dam. So, at the same location there was the bund breakage continuously over the years. So, that not only the Kanagasheri polder, but the 2 other polders associated with this Kanagasheri polder were also affected. So, you can see the kind of construction which has been made over there, the remains are already there. Coconut trunks were inserted into both sides of the bunch. Coconut trunks of length 12 meters were driven down using machines on 2 sides of the bunch, and in between they were connected by arecanut poles or other kinds of say wood which were sustaining in water. Kaya geotextiles also was used as interlying say as reinforcement in between, and in between they connected this with coconut say poles just like that, coconut beams just like that, and they constructed the bunch. Many a times whenever there is breakage of bund, they made use of sandbags also to prevent such kind of a leakage, but nothing was fruitful over there. So, a methodology to take care of this kind of a bund is also a question in front of us. That is also at the anvil of design. So, the picture has been taken as one of the major to show one of the major bund breakage which is happening in Kuttanad. And now let us go to the environment friendly way of polder wall construction. So, let us examine what is happening in the polder walls. The existing polder walls or bunds are either earthen bunds or dry rubble masonry or random rubble masonry. DR is for dry rubble and RR is for random rubble. In random rubble they use mortar also, cement mortar also along with the masonry, so to fill the gaps in between. That is impervious kind of a masonry if it is constructed properly. But dry rubble is a pervious masonry in which you cannot use any cement mortar because it is constructed inside water. From the clay layer, from the say founding soil to the water to the water layer, they construct this dry rubble, and above that they construct the random rubble. That is how they do it. So the dry rubble constructed below will be pervious. So what will pass through the dry rubble to the soil, and that also may cause some trouble. So we will discuss that in detail. The following are the challenges in bund construction in general. Let us see them one by one. The carrying capacity of the water body and depth of water, as we discussed in the first picture, the depth of water over there was like 8 meters. That is a major challenge. So carrying capacity, what is the total carrying capacity of the water body over there, what is the depth of water in the water body, and what is the depth of the polder on the other side. And then the velocity of water in the water bodies. The velocity changes. Depending upon the seasons, the velocity changes. Whenever there is a stormy season, the velocity may be enormous. Whenever there is a say wind blows, like the wind velocity is also is a parameter. So when the wind blows with a maybe during the afternoon, accordingly the water also will flow to the shore with like waves, and that may affect the earthen bunds for sure. Then the conventional and available materials for bund protection. What is the kind of material used, and what is the durability of that particular material is also a concern. Then engineering properties of the soil below the polders, whether sandy soil is available there, whether the soil has good bearing capacity, all these things are to be observed through certain soil investigation and through certain experiments in the laboratory. Then the cover of vegetation to the existing bund, whether the bund is covered by vegetation fully, so that the roots of that vegetation is sufficient enough to hold the soil together. The purpose for which the bunds are employed, whether the bund is employed for a polder, whether it is just like a water retaining structure, or whether it is constructed for some other just like a regulator, what is the purpose of the bund, that is also another challenge. Availability of construction materials including granite stones and unscientific use of the same. So this is included as a challenge because the total length of the bund, if you just count for the entire Kuttanad region, it may go beyond 1000 kilometers. And every bund, even if it is constructed with random rubble masonry or dry rubble masonry, that is to be improvised, that is to be retrofitted after say 5 years on an average, because the rubble will go down the soil and you have to retrofit that further. You have to pour or rather put rubble above that. So bringing sufficient rubble, sufficient granite stones to reconstruct and strengthen such kind of bunds is a challenge for sure. And that much amount of stones are not available even in the state, I would say. Quarries are supposed to be, some of the quarries are supposed to be closed also. So even if all the quarries work together, they cannot supply sufficient amount of say granite stones to reconstruct or to rebuild the kind of polder walls. That is also a challenge. And many a times, as I told you, the granite stones are not used in a scientific fashion. So engineered construction is also a matter of a concern, non-engineered construction. So how to use the rubble over there, whether the width of the rubble in the below the water is larger than the width of that above water. So these things are also to be seen if it is going at par with the design. Many a times what happens is, because the rubble which is going below water will be having less width, the wall will be having less width compared to that which is seen above the water level, because that is how some of the workers do that, that is how some of the contractors save their money. But what happens is there will be toppling of that particular structure, and it may finally lead to further reconstruction, retrofitting. So unscientific use. Then if you use concrete, so nowadays a new method of construction is pile and slab. Piles with concrete will be inserted into the soil on both sides, sometimes on the outer side, sometimes on the polder side also. They insert the piles into the soil, and in between the piles, concrete piles, they insert slabs, concrete slabs. So, that actually induces use of lot of concrete, and concrete, as we know, is a cause of carbon emission that will add to the carbon footprint. But one of the other disadvantages of using this pile and slab is that the pile will, though the pile may go deeper into the soil, the slabs may not go that much deeper. So, what happens is there will be seepage underneath the say slab, and that may pass from the water body to the polder. That may cause say underneath passage of water, and finally the bund may be getting broken. So, these are some of the things. Now, we can see some of the pictures which I have taken during an inspection of a polder. So, this polder is having a length of total length of 12 kilometers surrounding the paddy field. Then there is a big paddy field which was reclaimed land from Vembanad Lake. So, the polder has different kinds of walls. As you can see here, this is a very thin kind of a bund where the protection is of dry rubble. And as you can see, the dry rubble is now falling down, and the bund is getting weakened and weakened. Here you can see another dry rubble masonry, and in the top you can see also that there is a temporary protection with some kind of sheets, thin sheets also was made. It is also only for only stand for a short duration of time, and the thickness of bund is more vulnerable in these regions. Thickness is very small. Here you can see the thickness of bunds is varying. From on the right you can see there is vegetation, and there is protection by a private party, but in the middle you can see a shallow thickness of the particular bunch. Now, you can see here this is a private party's land where they have a banana plantation. So, there the thickness of bund is very much of the order of, let us say, 10 meters. The bund is protected with concrete, as you can see there, but the adjacent bund is having a very shallow thickness. And here you can see, because of the enormous wave effect, because of the wind speed, the waves will be there which is destroying the bunch. What they have done is the water hyacinth is collected together, and that is tied to the bunch, so that the wave effect can be reduced. So, we have to actually devise some methodology for reduction of this wave effect. Another peculiar say bund where you have a private party protecting his own bunch, but that is not continuous in the entire say structure. Here you can see very thin kind of bunds where there was a pump house originally. You can see the pump house was constructed in that particular land at the middle, but the adjacent bunds are very shallow. There is an opening from the bund to the water body on the other side. That became like a natural opening only when the bund was open, and the bund besides is very shallow in its width as well as depth also. You can see some of the coconut trees are coming down, falling down because of sand, the soil erosion. The bund is becoming very thin, and soil is getting eroded, and the vegetation is going off. So, those kind of features were noticed in the particular place. Here you can see another very shallow location of the bunch. On the other side, on the extreme side, you can see the water body, and towards us we can see that is the polder, place of the polder. So, we are traveling through the polder in a boat. So, the photograph is taken just like that. Another thin bunch. There is protection of the bunch through the coconut, the root of the coconut trees, but it is also very meager because the bund is having a very shallow cross section. There is every possibility that the bund may break at any point of time. Here another fissure in the bunch was also noticed. So, water is flowing continuously from the polder to the water body on the other side. Again, another location where there is a private party protecting his own bunch, but on the other side you can see the bund is not protected. Here kind of construction is there on the other shore of the bunch. So, you can see some buildings on stilts standing just like that in the bunch, but the bund protection is not taken care of very properly over there. Here erosion, soil erosion can be seen very clearly in the bund. The vegetation is also going off because of soil erosion. Another location of that particular polder where there is continuous breakage of bund. and they tried to protect the bund through erection of coconut trunks just like that, but they couldn't succeed over during every occasion. They couldn't succeed. That's what they told me. So the bund is under design. Again, certain other localities of the bund is also shown here, say kind of temporary protection using a kind of a sheet, a thin kind of a say a rubber sheet is made, but that is also only for a short duration of time. Another fissure you can see at the middle, and vegetation cover you can see in the bottom bunch. So that is with regard to one Padashekaram or one particular polder. And here you can see, this is a, on the left side you can see a lake. There is a big lake, and there is random variable protection for the outer bund of a polder on the right. But that was not enough, because when the flood water level was very high, they have to construct a temporary bund just like this above the rubble masonry, but that did not withstand. You can see the thickness of bund comes down when you go to the top. So the outer bund is now supposed to be designed. You can see such kind of bridges. You can see a bridge on the extreme end of that particular picture. The water body is having sufficient width, but the bridge is having a very shallow, less than the half the width of that particular water body. So the water body is restricted and the bridge is constructed over there. You can see such kind of bridges in many parts of water bodies in Kuttanad. And as a result, what happens is, as you see in the figure, as you see in the picture, water hyacinth, the flow of water through that particular water body is reduced. So that accumulation of water hyacinth is there, and that becomes like a menace. So certain proposed methodologies for polder wall construction is going to be discussed in the slides to follow. Right. So as the rubbles or granite stones settles and occupies the bed of water bodies, conventional biobunds may be promoted with certain modifications. You cannot have the conventional way of doing the bunch, but we have to have some certain modifications. So one experiment has been done already in the Tumburam Padashekaram at Nirupudi, which was explained in one of the previous segments. So gaining knowledge from that, you can have improvisation of that particular methodology also when we adapt that to another situation. So that bund was only biobund only, but the biobunds are subjected to scoring and soil erosion. So sufficient protection of the side wall should be given until the vegetation which is supposed to grow over there takes care of the bund. So that is very important, and reinforcement of the bund with Kair geotextiles or the cocolog is also required over there. So one of the reasons for this is that the rubbles can be used to an extent for bund protection, but the availability is also a question, and the settlement of the granites is also a question. So when we discuss with the people, they also tell that they are for this granite stones only, but after say 4 years or 5 years, they couldn't see even the stones. So if the granite stone wall is made for a height of, let's say 2 feet or 3 feet, after say 3 years or 4 years, you can see the height of the wall comes down to 1 feet or less than that. Sometimes the stones will go underwater also. So you have to reconstruct. So when we inspected such sites, we could see that to a length of, let's say 3 meters or 2 meters or 3 meters in the water body, we could see stones, because stones just spread out just like that into the water body, and that is causing trouble. Then Kair geotextiles reinforcement can be employed to improve the strength of subsoil. So we have proved in the laboratory also that when we reinforce the soil with Kair geotextiles, the CBR value, the California bearing ratio value is improved. That can be made use of, but after proper testing of soil in the particular site using Kair geotextiles as reinforcement. Wherever there is excessive erosion owing to water waves, you can use granite stones to arrest the wave velocity, and you can also use this rubber tires, unused rubber tires or thrown away rubber tires for as wave arresters. So these are going to be employed as design parameters in the particular site to reduce the effect of waves. Then the depth and the width of that is actually width, not width. Depth and width of bunds can be decided based on the maximum flood level. Well, that depends upon the situation, that depends upon the site. Then gates may be established in the bunds. That is also very important. Not only the protection of the entire polder with the bunds, but whenever it demands water has to flow into the polder through the bunds, and water has to remain there for some time, and finally the water has to be pumped out of the bund, pumped out of the polder. That is also required, because as we discussed in one of the previous segments, nearly 40% or more of the Wayanad lake or the water bodies are now converted into paddy fields. So, these wetlands or the paddy fields, they have to be used for water retaining for some time during the monsoon season, because the entire water system, wetland system in Kuttanad cannot withstand the amount of water which is coming during the monsoon season. The water has to remain there for some time, and the water has to be pumped out, so that the water should not go into the habitable areas of people. So, gates may be established in the bunds to regulate the inflow as well as outflow of water. That is the aim. This has to be designed depending upon the hydrology in that region. Then a research is going on in the laboratory of the Cochin University to produce bund protection materials, because the already available materials are very heavy. The rubble is a very heavy thing. Concrete is also adding, not only it adds carbon emission, but it adds weight to the soil also. It is also susceptible to settlement. So, lightweight materials at the same time having sufficient bending strength, having sufficient shear strength are required for the particular place. So, polymer composites or other kind of materials are being attempted in the laboratory, and whenever the outcome of such results are available, we can have another set of proposals or protocols for bund construction. Adaptable engineering is also required, right. It is not that the conventional engineering is required, but you require adaptable engineering, because the place has to be considered as a separate entity. It is not similar to other places. We have seen in one of the previous segments that when a design is brought from a hilly region to Kuttanad for construction, it was completely a failure. The design which is withstanding loads in a hilly region is not adaptable to the place, to Kuttanad. So, we require engineering which is pertinent to the place alone, right. So, that is the content of this particular segment. We discussed about some of the protocols for bund protection. Thank you.